So today we're going to talk about section 8.2, and in section 8.2 we're going to talk about adding signed numbers. So we're eventually going to narrow our work down to kind of a nice little concise rule that we're going to use for adding our signed numbers. But in order to help us kind of see where that rule comes from, and as we're going through, one thing that we've already mentioned is that our number line can be very, very useful for us as we're dealing with integers. So we're going to use that in these first couple of examples, along with something called vectors to show how we can add our signed numbers. So a linear length, the word linear referring to a straight line, right? So we're thinking about our number line, right? Can be given direction, either left or right, by placing an arrowhead at one end or the other. When we put that arrow on there and we draw this linear length, this is something that we call a vector. Right? So in this first example, we're going to represent each number as a vector starting at 0. And as we go through a lot of these problems in this section and the rest of this chapter, I'm going to try to keep things kind of nicely color-coded. Right? So you'll kind of see that as we go through some of these next examples. Right? So we're going to represent -5 starting at 0. Right? So that means for this vector, 0 is my starting point, right? And I want to move over to +5. Right? So I'm just going to grab a little ruler here. Just to make sure this looks nice. And we're going to take our vector and we're going to extend it on our number line until we hit the value of 5. Right? And that's where we're going to put our arrow. So notice that our stopping point here, right, is at this value of 5 on our number line. Right, next I'm going to represent -6 starting at 0. So again, I'm going to start at 0 here. Negative means we're going to the left, right? So we're going to represent this by a vector going, right, to the left that way, right? And then our arrow goes there, so this vector stops at a value of -6. For the most part, you're not going to have to worry too much about drawing these different vectors out because you're doing your homework in MyMathLab, but it is something to kind of keep in mind, or as you're going through, if it does help you to visually have these in front of you, definitely feel free to do so. Right. Then in our second example here, we're going to do the same thing. The only difference is here, instead of starting at 0, we're starting at another point. So we're going to represent +4 starting at 1. So I'm going to put my little dot above the 1. Positive means we're going to the right. So I'm going to extend my line to the right. Right, and as we're extending, we're counting 4 spaces. Right, 1, 2, 3, 4, which means that this vector ends at a value of 5. Now, if we start at -1 and we want to represent -4, right, starting at 1, representing -4, well, now we're going to go to the left 4 spaces. So 1, 2, 3, 4 means we're going to end at -3. So we end at -3. Right, now, why these vectors are useful? Basically, what we've just done here is we've just done an addition problem of signed numbers. Right? This problem here says the same thing if we take 1, because that was our starting point, +4, right? That gave us our stopping point of 5. Right? Now, if we go this way, we have 1, right, -4, or we could write it as 1 plus -4. Right? Either way, we stopped at -3. And this idea of using our vectors and moving left and right is going to give us a way to do our addition of our signed numbers.